Sir.
Good evening, Aditya. How are you?
Yes,
Everything
sir, I'm fine.
fine?
Sir. Yes, sir. Yes, sir.
Okay, you are in a comfortable place. Both are.
Yes.
Both are comfortable place. Okay, shall we start?
Yes, sir.
Okay, Avinas. Okay, first ready for that your main priority. You have to change your identity. It's very important. Start with identity changing. Take the hand with keep it in your heart nearby. You have the 100% responsibility to attend the live class. You are the committed. Okay, you are always remember you are the committed to become a energy auditor. Certified energy auditor, you become a specialist. Always feel like this. You are 100% responsibility. And you are 100% committed person. Whatever you are studying, you have to focus on the implementation. 20% learning, 80% implementation. I'm always focus on sharing the knowledge with our group community. It's very important. Always you focus on that. It's very important. Every month I will something I will post or something I will share with our community. It's very important. Always remember. Okay, are you ready?
Yes, sir.
Okay. Who are you? You feel it yourself? Avinas, Aditya, just I'm asking you, who are you?
Energy Auditor.
Okay. Aditya?
Yes, sir. Energy Auditor, sir.
Okay.
Energy.
Super. Okay. Today topic is chapter 4. Before you have studied HVAC review system. What is the meaning of HVAC?
Heating, ventilation, and air conditioning, sir.
Okay. Avinas, you know now?
Yes, sir.
Okay. We are going to discuss this topic. This is a topic. Just we are go through this topic. We are focused on the calculation, main important concept. Calculation. Okay. The chapter have the topics, the psychometric and the air conditioning process. What are the types and application of HVAC and the review system in industry? Comparison of energy performance of various type of HVAC and review system. Performance assessment of room air conditioner, our room AC. The performance assessment factors and the energy efficiency. It's a basic. All the equipment we have to do this one. Performance assessment. Heat pump is very important. Another application. Ice bank system. Sometimes they ask 1 mark or 2 mark. And humidification is a textile unit. It's a very important. 5 mark or 1 mark. And standard labeling. What is the standard labeling program for air conditioner? And energy saving opportunities. You know that HVAC means heat, ventilation, air conditioner, and a review system. This is an introduction. We are going to see that the heating, ventilation, air condition, and review system. This chapter fully focus on this one. Only the main concept, transform the heat, energy from or any other, from a product or building environment, anything. I will share it. Simple concept. The water have temperature. This is water. This box is a water, inside water. Okay, that is a 30 degree. Okay, I want to reduce this water temperature . -20 degree. What is the process? So 20 degree. What is the process? The water (1 to 2). 30 degree to 20 degree. What is the main process? This is what I am doing exactly. You are removing heat from water. Are you understand?
Yes.
Yes. Remove the heat. It's a two type available. Always remember. Heat energy, temperature. heat energy and temperature. Always you have to remember heat energy and temperature. Okay. What is the heat energy? What is heat energy? Energy means work done. Something energy that is work on something, it is converting some work. Understand? Heat energy means something using for work. Using for work. I need this much of energy, but I need to keep it temperature constant. That is also possible, na? It's a work. What is the here process? We are reducing the temperature 30 degree to 20 degree. 32 degree. Suppose heat energy reduce or increase, something happen. Actually, we are reducing the temperature 32 to 20 degree. Inside the, we are reducing the all the calorie value, the comfortable solution. You are removing the all the heat energy from here. Then automatically reduce the temperature. Are you understand? It is a heat removing. Heat removing. Then automatically temperature reduce. That means heat rejected. Are you understand? What is the process? What is the process? Heat rejected. How much heat rejected? How to calculate how much heat rejected? How to calculate? How to calculate? How to calculate how much? Because temperature, there is a normal temperature, but we have to convert to energy. So, how to calculate how much heat energy rejected? Any idea? What is power? What is the meaning of power and energy? Because it is a 1 kilowatt means per hour. Suppose that power utilized for some motor application, some running, continuously running, that is total energy utilized for motor running. That is the energy converting. For 2 hours, 3 hours, we are giving continuously whole the multiplication. It is a energy conversion. Same like this. How to calculate this heat energy? How much heat energy rejected? Any idea? What is the unit? What is the unit? And what is the unit? Any idea?
Sorry, by using MCP delta T, sir, temperature difference.
Yes, yes. That is a heat energy rejected. MCB delta, basic. This is a basic. Heat energy MCB delta T. Okay? Because only this is temperature. This is only temperature. This is only temperature. This is a, what is meaning? This is something mass. Are you understand? Something mass. Flowing per kg per hour. Can you understand a kg per hour? How much mass flowing? What is the CP?
Specific heat, sir.
Specific heat. The specific heat. What is the unit? What is the unit? Any idea?
Kilojoule per kg, sir.
Heat
Kilojoule.
energy. What is the main unit? What is the heat energy main unit? 2 unit available. You can use kcalorie or kilojoule. Kcalorie. First we will take it kcalorie. Are you understand? Na? Kcalorie. Heat energy rejected kcalorie per hour. we can use K-calorie/hour, kg/hour. Okay. First, we are taking K-calorie/hour. What is the unit here? Tell me, what is the unit? What is the unit? K-calorie, kg, degree Celsius. Why they are giving K-calorie per kg degree Celsius? Why specific heat required? Why specific heat required? What is the difference? Why specific heat required? Any idea? Why specific heat? Because all the material have different temperature. So suppose you take water. Water, you compare with the solid. So water with oil. Okay? Water, which is a density high? Which is a density high? Density.
Water, sir, water.
Water.
Yes, sir.
Okay, you take solid, any solid. Which is density high?
Water.
The density. Density is high. Okay. Oil, density low. Solid. Just take it petrol. Solid, density high, na? Solid density very high. Can you understand? Any difference? Here I draw the density. Always remember, solid density high. Water, gas. Okay. Solid density very high compared to water. Water says water density high compared to gas. Are you understand now? Are you understand? Now you see backward. From this word, you can see solid density high compared to water. From this side, gas density low compared to water. Water density very low compared to solid. Can you understand? So once you heat the water or solid, which is quickly pick the heat, solid, water or gas. If you are heating the 1 kg of solid, 1 kg of water, 1 kg of gas, which is getting quick and fast getting heat, which getting quick heat, which is getting quick heat. Tell me. For 1 kg. Any idea?
Gas, hydrogen.
Yes, which is getting quick heat. So gas. Getting quick heat. Very, very important. So quick getting gas. Gas quickly getting. Solid, so water next. Solid next. Are you understand? Na? The quick getting, this is a very quick. The first one. Next,
Yes.
second. It's a third. It's a quick. This is a less than gas. It's a less than water. So then which one having the specific heat very high, very low? Which one have specific heat very high, very low? Specific heat means simply we can easily understand. Avinash basically working. He said he will working 100 job completed per 1 hour. Per 1 hour he completed 100 job. Aditya completing 50 job per 1 hour. Are you understand?
Yes, sir.
Same concept. So if 1 hour for 1 kg, just increase the 1 degree Celsius, it will getting pick up 100 kcal. Like this. That is a specific heat. If you are, this is a 1 kg, this is a 1 kg, anything, 1 kg solid, 1 kg solid. Okay, I am going to increase the temperature. This is solid. 1 degree Celsius increase. Then this is 1 kg. Then how much kcal? How much kcal added? That is a specific heat. So that randomly, not randomly, they predefined. For water, 1 kcal per kg degree Celsius. For water. For gas, something they will give. Solid they will give. So specific heat always they are giving the value. The specific heat value they always giving the value. So what is the unit now? Tell me. Now you understand, na? Solid, the specific heat very high or low? Solid specific heat very high or low? Same water you are boiling. It's a water. Okay, 1 kg water. It is a normally 30 degrees Celsius. Now increase 1 degree Celsius. Then how much kcal added for water? This is for water. 30 degrees Celsius, how much kcal added? What is the specific heat? What is specific heat? What is specific heat for water? For water, always remember, for water, 1 degree Celsius means 1 kcal. 1 degree means 1 kcal. Then what is the specific heat? What is the specific heat? What is the specific heat? One kcal per kg degree Celsius. For 1 degree Celsius increase the water, 1 degree increase, then 1 kcal added for 1 kg. Are you understand? Always remember 1 degree Celsius, 1 kg water, how much kcal added? That is a very, very important. Now clear the point? Same. For 1 hour, how much work you have done? For 1 hour, how much work you have done? Same concept. For 1 kg, now increase 1 degree Celsius, how much kcal added? That is a water for 1 kcal. But solid, higher or low? Solid, higher or low? Quickly tell me. Solid. Avinash, for solid, specific heat high or low? Are you available?
High.
High na? Are you understand? So what about the gas? What about the gas?
Medium range.
Always remember, solid always high, water
Then gas.
is gas. Okay, this is very important specific heat. Always remember, don't forget this one. Specific heat, unit what is a kcalmole, kg degree Celsius, or otherwise kilojoule, kg degree Celsius. Now you understand na? What type of unit you have to use. Okay, both unit, but you have to convert. Okay, now this is now is a kcalmole. What is the next one? What is the other? Suppose R. Suppose they are giving the specific heat. Giving the specific heat kilojoule per kg degree Celsius. Then what you will do it? This also temperature also same degree Celsius. Then here also mass kg per hour. Then what is the unit? What is the unit here? You check kg cancel. Here kilojoule only available. Celsius cancel. Then what is the final unit? Kilojoule per hour. Now clear? Unit. The kg is a kg. Degree Celsius cancel. Okay, this is a basic formula. Okay. Now tell me 1 kcal equal to how much kilojoule? 1 kcal equal to how much kilojoule? Tell me quickly. 4.187 kilojoule. Okay. Already we have discussed. 1 kilowatt hour equal to how much kcal? Kilowatt hour. Tell me quickly. 1 kilowatt hour. Any idea? Always remember 860 kcal. Kcal. If hour means you have to put it hour. No issue. Per hour. This is electrical energy. This is a thermal energy. Are you understand? This is electrical energy. Electrical energy. This is thermal energy. Okay, now the point basic concept completed. Are you understand all the basic concept? This is a basic. If you remove the one heat from the water, then automatically reduce the temperature 32 degree. Then using the formula MCB delta D. Delta D, how much temperature? 30 minus 20, 10 degree. 10 degree, you multiply with the mass, you get it all the kcal. Quickly done. Water mass, you just put it, specific heat 1 and delta T 20, then multiply, you get it this one. Suppose specific heat they are giving the kilojoule, you have to change kilojoule. Then finally you convert to kcal. Now tell me, 4,800 kilojoule. This is 1 mark. 1 kilojoule equal to how much kcal? Tell me quickly. 4,187 kilojoule equal to how much kcal? Tell me quickly. Doing Avinash? Yeah, Aditya?
Yes, sir, doing.
Yes, tell me.
1000, sir.
Okay, correct. So 4187 equal divided by 4.187. So 1000 kcalorie. This is you have to convert everything. Okay, you have to convert everything like this. Okay, next we will discuss basic loop. Very important. The energy in form of electricity or heat. The energy in the form of electricity or heat is used to power mechanical equipment designed to transform the heat from colder, low energy level to warmer. What is the basic concept? Now I remove the heat energy from here 30 degree to 20 degree. Then it is going to atmospheric. This is a low energy to high energy. It's a basic concept. Low energy level to warmer area. We are transforming the energy. The refrigeration deals with the transform of heat from low temperature level at the heat source. What is the heat source? Low temperature level heat source to a high temperature level heat sink. Very important one mark. By using low boiling refrigeration system. Low boiling refrigerant. Our AC room, our room is a compared to inside the room temperature always less compared to outside. So what is the meaning? Inside some low boiling refrigeration available that is taking the temperature from the room, then boiling convert to that is going to release the outside. That is a basic concept. Air conditioning system, AAC. Air condition is a comfort zone. It's creating comfort or machine. The split air, what are the type available? The several options available. Just we will study the fan coil unit, air handler unit. We are going to discuss this air coil calculation also available. The split AC, energy efficiency ratio we will convert. This everything we will doing. And main important industry level. Always remember, industry have 3 level. The review system, air conditioner. What is the 3 level? Comfort air conditioner, 20 to 25, very important one mark. Chilled water system. Chilled water means industry chilled water, 8 to 10. The brain system, sub-zero application. Sub-zero means below the zero. The basic principle. What is the basic principle they are using? All the system working 2 principle. One is a vapor compression reverse system. Another is a vapor absorber reverse system. VAR, VCR. This is a very important 5 mark, 10 mark calculation. Compression. What is means compression? The compression, absorption. Compression always remember compressor using. Here always using compressor. Compressor, what is energy? Compressor, the mechanical energy. VCR always use mechanical energy as a driving force for reverse system. Always remember VAR, absorbs means thermal energy as a driving force for reverse system. Okay, very important. This is very important one mark. I will draw the diagram next, then we can easily understand. The vapor combustion always commonly the heat flow naturally from hot to colder area. Hot to colder area. The reverse system has opposite. Always remember this opposite system. Always heat flow cold to hotter area. Very important basic concept one mark. This is achieved by using any other material they are using. What type of material? What is the name? The substance is called the refrigerant. What is it called? The refrigerant. This is a very important one mark. What is the main work? It's absorb the heat. What is the meaning? This is absorb the heat, the boiling or evaporate. It's a low pressure. If low pressure means low temperature, it convert to gas. Then what will happen? Then next going to compressor, then compressor, then going to condenser. Condenser release a temperature to outside. That we are going to take one simple diagram, you can easily understand. I draw the diagram. The basic the VCR or heat pump. It's a motor, the connector with compressor. Condenser. Here is a cooling tower. This is a evaporator. Okay. This is evaporator. Now cycle we have to check. Always remember, this is going to here. This cycle, this heat energy going to where is going? The condenser. Then after what happen? It's reduce the temperature. Then going to expand valve. Then going to here. Evaporator. I will write it one by one. What are the things? It's a compressor. It's a motor. Motor. It's a compressor. It's a evaporator. Expanse valve. Is a condenser. Is a cooling tower. CT. Okay, now what is the process? Any idea? Process? Here is our room available. Just you see our room. Simple diagram. Here is our room available like this. Our room. It's a very industrial room. Here taking temperature, then releasing. Inside taking hot air, then convert to cold air. This is how it work. Now here always remember, you are setting the room temperature 25 degree. So 20 degrees Celsius. Then automatically here the refrigerant always about 20 degree. What will happen? Here inside available refrigerant, what will happen? What is our refrigerant? About 20 degree boil. Okay, about 20 degree boil. What will happen? About 20 degree, it will boiling. Then what will happen? Evaporator transfer the heat to here cycle. Then what is the work? It is a temperature high. What is the work of compressor? This is a compressor. What is the work of compressor? Any idea? Compressing. Increase the pressure. Here is a pressure low. The P, pressure low. Two function always work. Here going means what will happen? Temperature increase. This is also temperature adding. What is the temperature adding? The temperature means the K calorie, heat energy added here. Always remember, here always, after the compressor, always remember, heat energy added. Always remember, I will keep it 1, 2, 3. You can easily understand. This is a 1. This is a 2. This is a 3. This is a 4. So what is the heat energy? 1 plus 2. 1 plus 2. Then heat energy added and pressure also increase. Then pressure also increase. This cycle. Then next going, we are going, next one. Condenser. What is the main job for condenser? Releasing the temperature in atmospheric. Then cooling tower water flowing like this. Then cooling tower water flowing here coming. Then take it to here like this. Coming down, always release, heat energy release, atmospheric. The cooling tower condenser working. Then what will happen after the condenser? After the condenser, what will happen? What will happen after the condenser? After the condenser, what will happen? Any idea? Temperature reduce. Only one job. Temperature reduce. Then what will happen? Next cycle. Pressure always keep it same. Okay, pressure reduce little bit, but not consider this one. Only temperature, always focus on temperature reduce. Then what will happen? Here going to expanse valve. What is expanse valve? Pressure also reduce, temperature also reduce. This is job. Then again going here, evaporator, same concept rotating, continuously rotating. It's a motor, condenser, expanse valve, evaporator. Evaporator job, removing the heat from room. The evaporator job is removing heat from the room. Heat from room. Very important. Then the temperature increase. Pressure. I need to build up the pressure. Then only I can take it to condenser. I want to release that heat energy. Na? I can't circulate continuously because each and every time I cannot add the refrigerant. Are you understand? Once you fit the AC, automatically once year continuously automatically running. After the 1 year, I will change something. That is my job. But each and every day, not possible. So that everything rotating. Automatically you have to do cycle process. Then condenser job that remove the heat energy. Then again, then going, continuously going on. This is a cooling tower. Then expanse valve. What is the expanse valve? Reduce the pressure, temperature. Then going to evaporator, same cycle going on. Any idea? Any issue? Are you understand clearly? What is the condenser heat energy rejected? How much condenser heat energy rejected? Condenser, how much heat energy rejected? Aditya?
Sir, that heat that is gained during removing the heat from the evaporator, sir.
Yes, how much? How much heat energy rejected? Here. Some heat load. That means you can easily understand heat load. Very, you can easily understand how much heat load in condenser. That is very specifically we can heat load. At condenser. Very important. 1 mark and 10 mark basic concept. How much heat energy in condenser? Heat load. 1 plus 2, na? 1 plus 2. What is 1? The evaporator. Yes. There. Yes. Tons of refrigeration. This is heat load. Say evaporator plus condenser. That is a very important. This both load is a condenser heat load. Okay. What is the next? What is the compressor? Very important. We have to always focus on. Sometimes they give the compressor motor input and motor efficiency. Sometimes not given. Only they give the motor input. So don't confuse with this one. Always remember, if you what is the work here going on? What is the work going on here? Only the compressor work going on. This is a compressor work doing. So if motor, they're giving the motor input, power input, and giving the motor efficiency, always you have to remember, you have to find out, what you have to find out? Motor shaft power, otherwise compressor power input. Are you understand? The motor shaft, P shaft equal to compressor input power. This is you have to find out. For calculation, you have to find out the calculation, some COP, cooperation of performance. Then you have to find out the motor compressor power input. Sometimes they not given the motor efficiency. Then what will you have to? You have to take it power input. Okay, no issue for this. Maximum they will give the efficiency, no issue. Are you understand? Sometimes they give the power shaft input. They will ask power input. They will give the efficiency. Then you have to find out. This diagram, everything clear? Avinash?
Repeat one time, sir.
Your voice not clear, Avinash.
I said, sir, repeat one time, sir.
Repeat. Okay. This is your room. You are fit the AC. This AC, this equipment, all thing available. Evaporator, compressor, the motor, and condenser. That is a cooling tower. That is a industrial applicable. Then expanse valve. Then you set the temperature 20 degree. You are inside 30 degree. So you have to reduce 10 degree. So 10 degree means the evaporator above the 10 degree, all the air temperature with this liquid inside refrigerant available that absorb the heat above the 20 degree, then boil, then heat energy going through here. That is a temperature high, but pressure is low. So what is the purpose of motor and compressor? So something we have to add, increase the pressure, then going to condenser. Then what will happen? The compressor once run, the temperature and heat load added and pressure also added. Then going to condenser. So easily going to condenser, it will reach. Then condenser, what is a work condenser? It remove the, what is the main job? It remove the heat from the refrigerant. Then what will happen? Temperature release, then going to expanse valve. What is the expanse valve job? Tell me, Avinash, what is expanse valve job?
Pressure decreases.
Yes, pressure decrease. Then automatic cyclic going on without anyone interrupt. In your AC, in your room, you have some AC in your room. You are disturb. Only you change the temperature. Na? You are not disturb anything, nothing. Na? That is basic work principle. This is one. Then finally the point of question: how much heat energy, how much heat load in condenser? They will ask. How much heat load? How much heat load? How much heat load condenser? Always remember the motor running. Na? The motor always remember motor if running means that is also giving produce the heat load. Motor running, compressor running means that is also giving heat load. This heat load, heat load, both add. That is a condenser heat load. This is very important. Up to energy audit, you have to understand this basic concept. Maximum they will ask like this question every time energy auditing. Okay. Now you understand, Avinash?
Yes.
Okay. Just this main concept, within 1 minute you have to explain. There was a 48, 49. Quickly, explain quickly. Avinash and Aditya. Start, Avinash, quickly.
This is the motor, sir, where the compressor attached. Now that Compressor goes to condenser where the temperature is remain constant and pressure also. And after that it goes to condenser process and where the temperature decreases. And after the
Okay.
expansion value, the pressures decreases and the temperature also decreases and goes to evaporation pressure where the room hitting the pressure.
Okay. This is continuously doing the evaporator continuously cycle going on. Okay.
Yes.
Aditya, tell me quickly. Super, Avinas. Super. Quickly started.
Yes, sir. So, sir, basic aim of the refrigeration cycle is evaporator, where heat exchange takes place in the room. So there is a initial before evaporator there is expansion valve where pressure is reduced and temperature is also reduced. That refrigerant is circulated to the evaporator, where it cools down, where it exchanges the heat into the room. Further, there is rise in temperature in the evaporator, so it goes to compressor where there is external work is done using motor. So there is temperature rise and pressure drop in the compressor.
No,
Further,
pressure, main purpose, pressure increase. You see na
pressure
pressure,
increase.
compressor,
Initially,
compress.
yes, sir. Yes, sir. Initially, it is with less pressure, and after compression,
Yes.
increase in
Yes.
pressure.
One point you had on it. This is input, output. Always remember, this is input. Sometimes they will give you some like this question also. This is a compressor input. This is
Yes,
a
sir.
compressor output. This is input, the input side.
Hmm.
Every equipment always remember. This is output side.
Yes, sir.
So input side low, output is very high. Okay, that is very important. Super point.
Yes, sir. So pressure
Okay.
increases. Then when it enters, refrigerant enters in the condenser, it exchanges the heat with the surrounding, and there is a temperature drop. Further, it is moved to expansion valve, and this cycle continues. This is refrigeration.
Okay, super, Aditya. Avinas, you understand well. Okay, appreciate yourself. Super. Then we will start with simple formula. Already we know formula. Already you told MCP delta D. That is we are going to discuss. This cycle also simple. We can explain during the theory, same cycle. There is no extra concept. This is a main concept. Now concept understand na? This book,
Yes, sir.
total calculus, this is a basic concept. Okay, wait. Next is a very important formula. This one formula for the refrigerator plant. Okay, always remember the cooling effect is produced quantified. Always remember, very important. What is the quantified? Tons of refrigerator system. What is we are calling power? We are calling power. What is we are calling power? Kilowatt na? Energy kilowatt hour. Same concept for cooling effect. Always tons of refrigerator system. So 1 TR equal to 3024 kcal per heat rejected. This one mark. Heat absorbed or heat rejected? Heat rejected. This is a very important. 1 TR equal to 3024 kcal per hour heat rejected. Okay. Then you can see na in ad is coming 1 ton AC, 2 ton AC like this.
Yes, sir. Yes, sir.
Yes, this is called 1 ton of refrigerator system equal to same basic formula. What is the basic formula? MCB delta T. MCB delta T. This is a cake. This is a kcal formula. You convert to tons of refrigerator means just divided by 3024 because 1 TR equal to 3024. You have to convert. I need to one how much ton? So you have to divide by 3024. So same. See M, you can use M or Q, nothing. There is no difference. Same concept. Na? This is M na mass.
Yes.
The mass of flow, the kg per hour. CP, okay. Temperature difference. Very important temperature difference.
Input out.
Yes. Input, output. So input is the refrigerator system. You understand? Refrigerator inside he is inside input na. This
Yes.
always high na. Temperature high. This is a temperature out. Always out is a low. So temperature high. Whatever, always remember high.
Input
Is
high.
a high. This is a low. The high minus low divided by 3024. Divided by 3024. So Cp is a coolant or a specific heat. Kcal per kg degree Celsius. Ti is a inlet temperature. The coolant of chiller input. The chiller input na, that is a input chiller. Then outlet temperature means the coolant of from evaporator output. The chiller output. The outlet temperature. The above TR also chilled. as a chiller tonnage. Sometime the above TR also, sometimes they ask chiller tonnage. How much chiller tonnage? Sometimes they ask, na, what is the tonnage of your AC? Simple shortcut. What is the tonnage of chiller? You just tell, okay, 210 or 20, 200 tons, 100 tons, like this. Shortcut. This is a very important formula. Always remember, this is a very important formula. What is the formula? Always remember 1 TR equal to how much?
3024.
3024 kcal per hour.
Heat rejected.
Heat rejected. Heat rejected. Okay. Then formula. So TR formula equal to mass Q into Cp into delta T. So Ti minus T out divided by 3024. That is a formula. It is very important formula. Simple formula. Always remember. Then specific power. Very important. What is the compressor specific power consumption? Always remember, specific power consumption means power always come first. Kilowatt divided by CFM per compressor. Same concept. Specific power consumption for revenue system, kilowatt divided by TR. Are you understand?
Yes.
Very important formula. Specific power consumption equal to kilowatt. Always remember, power always come top side. Don't forget this one, okay? Kilowatt divided by TR. What is a shortcut? Input divided by output. Opposite for efficiency. Always remember, input divided by output. Na? This is specific power consumption. Kilowatt divided by TR. Very important, 1 mark. Sometimes they ask, what are the components available? Chiller, compressor available, chiller, water pump. You need, na? Everything you need. Here, water pump need, na? Are you understand? I am writing only single diagram. Here also pump available. Here also pump available. So compressor, here pump available. Here also pump available. Anything need pump. Something pump need for flowing. So chilled water pump, condenser water pump, cooling tower fan for cooling effect. The induced or post up that we will discuss. Sometimes they ask specific power consumption for each unit. Then compressor, same formula for compressor, kilowatt divided by TR. The chilled water pump, kilowatt by DR. The condenser, same, kilowatt divided by TR. The cooling tower, same. What is the specific power consumption for cooling tower? Cooling tower fan. The cooling tower fan,
Kilowatt.
suppose 100 kilowatt, 100 divided by how much TR total plant? Suppose
3024.
200 TR. Just make it like this. For example, the specific power consumption. Plant. The plant is 100 TR. Okay. Power consumed. Power, compressor power. Power. Power input to compressor. $200 kilowatt. What is the specific power consumption? What is specific power consumption? What is specific power consumption? Any idea? Tell me quickly. Specific power consumption. Quickly tell me, Aditya. Always know power. Power means top will come. So input divided by output. What is input? Power 200. What is the output? 100. Kilowatt divided by TR. What is the final value? 2
2
kilowatt
kilowatt.
by TR. Clear?
Yes.
Yes.
Simple, everything. Next is a very important coefficient performance. Very important. The coefficient performance. Then suppose they'll ask overall means just add everything. Sum of everything. Overall kilowatt divided by TR. Everything add, that is fine. Once we do the calculation, you can easily understand. Another one is a coefficient performance review system. Very important. Two formula available. COP. Very important. Always they ask me 1 mark. This is a Carnot cycle. This is a standard measure. Only the using temperature. The standard measure using that, the review system depends on the two key system. One is a temperature, namely the evaporator. What is the temperature? Is evaporator temperature. The contents temperature is a measuring. Which using the temperature, they are measuring the COP. How to do the COP? Coefficient of performance. The coefficient performance, what is the performance? How done this performance? We have to measure. Who done the performance? Who done the cooling effect? Which one is done cooling effect? Compressor or evaporator? Okay, evaporator na? Always remember evaporator. So, the evaporator. Okay, what is the input they are giving? What is the input?
Compressor power, sir.
Yes, compressor power. Always remember. So, COP means the cooling effect divided by compressor input. Same concept for using the temperature. Always remember COP, the coefficient performance, two formula available. COP is a two formula available. Very important. COP, two formula. One is using temperature. Using temperature. Okay. Always remember. What is the temperature? Here you see. Is a evaporator temperature. TE. It is a compressor. Sorry, it is a compressor. How to do the compressor calculation temperature? It's a condenser temperature. We can easily measure the condenser temperature. So how to calculate compressor temperature? How to calculate compressor temperature? Any idea? TC minus TE. Clear? The condenser heat load equal to compressor plus evaporator. Na? Are you right? Are you right? Are you understand?
Yes,
The condenser equal to the evaporator plus compressor. Now I need compressor. Then the condenser minus evaporator. That is finished. Always remember condenser heat equal to evaporator heat plus compressor heat. Heat or temperature. Heat or temperature. Heat or temperature. Heat or temperature. Okay. Now using temperature. So what is the coefficient of performance as per the Carnot cycle? Cooling effect, very important. Basic thermal cooling effect. So what is the cooling effect done? With using temperature. Set evaporator temperature. Na? Then condenser compressor input. The compressor heat energy or compressor temperature. What is the how to calculate compressor temperature? This is a TE. This is a TC. I need compressor. So compressor heat. Compressor heat temperature equal to TC minus TE. Okay. TC minus TE. Clear? This is with using temperature. Next formula with using cooling effect. Heat energy. What is the formula? Next one is a 2. COP equal to cooling effect in kilowatt. Always you have to remember, always if divided means you have to use same unit. Don't forget. Cooling effect in kilowatt divided by power input to compressor in kilowatt. Always remember same unit use. Top and bottom same unit. Clear?
Okay, sir.
Top and bottom same unit. Don't change it. You have to convert. Suppose TR means you have to convert to kilowatt. Okay, this is a basic formula. Already understand the COP equal to the evaporation temperature divided by TC minus TE. Then this is a very important. The cooling effect kilowatt power input to the compressor. This is another formula. Always we are using this formula. Rare case we are using for 1 mark this formula. These two formula very important. Okay. Up to now, how you understand? What is your learning?
Rating. Good,
Rating.
sir.
Good.
10 out of 10.
Aditya?
Yes, sir.
Aditya?
Great, sir. Yes, sir.
Okay,
It was
okay.
nice, sir.
Okay,
Super,
thanks,
super,
sir.
super, Aditya.